afternoon, everybody. First, I'm co-founder of Quadrical.ai, which is an AI company with an office in Waterloo in Canada and a second office in Gurgaon, just outside New Delhi. As you can probably guess from my accent, I'm based in the Canadian office, but I really want to start my talk by saying I'm very deeply honored to be here at India's premier AI conference and talking to an audience like this. Also, as I look around the room, I have to admit that I'm a little envious. There are a lot of people here with a lot less white hair, gray hair than I have. And as Mr. Vikram said this morning, AI is just about to take off, right? It's the get in the seat, fasten your seat belts, the next decade is going to be fun. So, for the people in this room who've made the decision to be in AI and are at the beginning of their careers, with that ability to harness the technology, should be a fantastic career. So, let me get on to my actual talk itself. So the title of the talk is Artificial Intelligence, a Non-Disruptive, Disruptive Technology. I'm going to break the talk into three parts. The first one is just to give everybody in the room an idea of what the Canadian artificial intelligence ecosystem actually looks like. The second part will get into what's happening with most recent changes from my perspective in AI in a commercial field and AI from a technical perspective. And then I'll take a quick look at how do the market leaders avoid being disrupted by the emergence of AI. And I think the great news is it's eminently possible for existing market leaders to avoid being disrupted as long as they embrace AI now. The slight downside on that is it is very late in the game, right? This is not a point to be sitting and saying, we need to think about this. This is a point for action. So let's move on a little bit. So to talk about the infrastructure, let me see if I can do this. No, it's not showing up. If you look at the top right-hand side of the screen there, you'll see four red circles. Canada's AI emphasis is primarily in a very thin corridor stretching from Montreal down to Waterloo. Right? If you think about the locations, Montreal has the McGill University and Université de Montréal, where Yoshua Bengio's group is based. Yoshua Bengio, for those people who aren't familiar with him, was the most cited computer scientist. Forget about AI, computer science in general. In 2018. He's also co-author of the deep learning book, the one with the pillars and dog on the front, for anyone who's actually read it. And very significantly, he's also one of the co-authors of the recent paper on generative adversarial networks. Right? Coming down a little bit, we reach Ottawa. Ottawa is essentially a tech hub for Canada. Also seat of the federal government. And the federal government in Canada is being fairly forward-looking in terms of how it's dealing with AI. It's created something called the Vector Institute, and the Vector Institute is really a way of bringing academics, AI practitioners, and the companies that may be wanting to use AI together in a group to benefit, right? Coming down slightly further, we reach Ottawa. We reached Toronto. University of Toronto has always been a fairly big center for AI, probably most famous for Geoffrey Hinton. Geoffrey Hinton was the person who made backpropagation a practical proposition. So I think, there have been various people who've talked about backpropagation, but what Geoffrey Hinton did was made it accessible and made it practical. And then finally, right at the south of that slight crescent corridor is Waterloo, which is where one of the offices for Quadrical is based. Waterloo has Canada's premier engineering and computer science university, University of Waterloo. Not very, very innovative, but certainly basically a center of excellence. Waterloo also has top-class math, quantum computing, AI, and physics departments. So what I mean by top class, for example, is one of the 3 people who won the most recent Nobel Prize in physics is actually a professor at Waterloo. The other areas are also equally top class. So Waterloo, fantastic place to be. One other fact about Waterloo, just to keep people in mind, is the region around Waterloo has about 500,000 people. There are over 2,000 tech companies in Waterloo, and of those, around 200 are AI focused. So if you think, not a huge number, but if you think per capita, right, how many companies per person, very, very high proportion. So that's basically where most of the AI machine learning work is done in Canada as a whole. By the way, for the folks who are purists in terms of language, I sort of interchange between AI and machine learning. When I say AI in this particular talk, I'm primarily talking about the machine learning aspect of it. Okay, so let's go to the next one. So getting little bit closer to the topic of the conversation, artificial intelligence, right? It's, for us in this room, perhaps not a new technology, but for the populations as a whole, I think AI is one of those new great things. When you have something which is new and great, you almost always have ambitious predictions. So a couple of the ones that stood out for me was AI is expected to add about $15 trillion to the global economy over the next 10 years. And I suspect a fair amount of that $15 trillion is going to be right here in India. Another one is that AI will probably replace about 25% of the human-occupied jobs at the moment. But it's expected that the total number of jobs will increase. So it's not that it's going to make humans obsolete, it's the fact that it's going to add 25%. On the other side, you get the negative predictions, right? AI is going to completely disrupt business, AI is going to make humans irrelevant and put us all out of work. Now, I've been in disruptive technologies, or technologies which have been claimed to be disruptive, for about 30 years. And I've yet to come across a technology which has actually enabled me to work any less. So if the claim about AI is correct, I'll be delighted, I'll get a little bit of a rest, but somehow I don't think it's going to put us all out of a job. Keeping going, when we start thinking a little bit more deeply about AI, AI is undoubtedly changing how companies are going to be doing their work, right? But it doesn't necessarily have to change who those market leaders actually are. To understand this, let's go a little bit deeper, right? What's the real value of AI? Well, the real value of AI, if you look at it very superficially, is it can find patterns in very large amounts of data. But if we're slightly more precise, it can find those patterns which we as humans really can't. So it's a complementary technology, right? If you already know exactly how to model your process, AI isn't going to help you. If, on the other hand, you're struggling to find the pattern in the enormous amount of data that's available to you, then it does help you, and it doesn't replace the humans. So again, complementary nature. What makes it fascinating, and certainly from Quadrical's area, the ability to predict. So Quadrical's key product is a prediction algorithm, which I happen to think is fairly awesome. It takes into account both what's happening in the past and what's happening in the future, and the expectation of what the future events are actually going to be. But essentially that predictability sort of satisfies almost all of our desires to be able to look into the future and say, what is likely to happen? If you think about it, what AI really does for us is, if we have enough data and we have a specific enough question, then we can predict the near-term future. Okay? To try and phrase that in a way that it might resonate with folks in the hall. So Quadrical has a great prediction algorithm. If we were being asked to say who's likely to win the 2023 Cricket World Cup? That's going to be a little bit tough, right? 2023 is a fair distance out. There's a lot of things that might happen, and there's a fair chance the prediction's going to be wrong. On the other hand, if somebody was to say, take the T20 World Cup, right, in 2020, and try and predict who the winner of that is going to be, that's a much more realistic question. Much less data, much less time, and a very, very specific question, right? So let's move on again. So taking a look at what is changing, within the industry, I see three fundamental changes occurring. The first is democratization of AI. So basically, within AI, if you look at what's happened between about 2013 and about 2017, some of the key steps are the GPU manufacturers, companies like NVIDIA, for example, have made it possible for us to access the processing power of those GPUs. Companies like Google have open sourced their AI code, TensorFlow essentially, which makes it possible for us to get to the applications rather than spend our time building the infrastructure, right? And then finally, if you think about the cloud providers, Microsoft's Azure ML, AWS's Machine Learning Solutions Lab, these are making AI essentially accessible to a very, very large group of people and a very, very large group of companies. It's no longer really a specialist technology. The second thing is AI-aware corporate leadership. So the people who are graduating in the late 1980s and the 1990s, who are familiar with AI, are finally moving into those leadership positions within companies. Also, the people who made their money with successful big tech startups, those folks are beginning to influence corporate leadership as a whole. So AI-aware corporate leadership is leading to embracing AI and creating of things like data science divisions. Okay? The last thing is slightly less positive. AI is becoming far more complex, right? So if you think about 5 years, 6 years ago, there were quite useful solutions to be had by taking relatively simple data cleaning steps and taking fairly simple one-stage models and generating results. Now, if you start thinking about what is being applied, usually to have an effective model, the model involves a significant amount of data engineering, substantial data augmentation, and effectively 4 or 5 models with some type of fairly complex ensembling approach, right? So the point about the complexity is it's leading to specialization within companies. It's going to be difficult for somebody to be an expert in all the areas of AI, right? And this suggests that corporations have to be careful as they create AI departments. You've got to think about what is core to your business, what are you going to keep within house, versus what are you going to farm outside to the specialist companies, right? Let's take a look at what's changing in the AI tech field, right? So I broadly break AI machine learning into about 6 areas, right? Classification, outcome classification, predictions, price value predictions, anomaly detection, which can both be reliability within manufacturing or fraud detection, as our previous speaker was talking about. There's product ranking, product personalization, the vision, which includes object and image detection, and then the various communications aspects, natural language processing. So if we look about 5 years ago, I'm not going to talk through these technologies, but there's a bunch of words up there which I'm sure are familiar to most of the people sitting in the room. Things like isolation forests, one-class SVMs, convolutional neural nets, and so on. But if you were to say which of these techniques is current state of the art, right? There might be a few areas where you still might be using some of these techniques in order to deal with a specialist problem, but by no means are these state-of-the-art today. Even if we go to, where were we about 2 years ago, 2017-ish, right? In the classification area, for example, the boosted decision tree algorithms like CatBoost and XGBoost have really become fairly dominant in this area, right? Using LSTMs as a basis for your prediction algorithm, fairly substandard thing, and the idea of an autoencoder-decoder model in anomaly detection becoming fairly important. Most of what Quadrical does is the top lines. They're equivalent steps forward in the ranking, vision, and NLP areas, but I'm sure there's more people in the room who know a lot more about this. For example, I believe there's quite a good talk on NLP coming up tomorrow, so if you want to learn more about what's happening in NLP, attend that one. The point of what I want to get to, though, is this is probably the last 18 months worth of development. So the challenge with using a boosted decision tree for a classification type problem is boosted decision trees are sort of like Ferraris. They're excessively well tuned, but they're really, really sensitive to the idea of drift in the data. So if you're going to try and use something like a boosted decision tree for a classification problem, you need to augment it. There are some really nice augmentation models. Google's DeepFM, for example, combined with a boosted decision tree, will give you both the spectacular performance of the boosted decision tree, but also the robustness of a neural network, the DeepFM network itself. In the prediction space, one of the sensitivities around an LSTM is if data is actually missing, or the period between the data points is variable, then the performance of the LSTM degrades pretty quickly. There was a really good paper which came out about 12 months ago on ODE nets, and ODE nets look like they have the capacity to deal with time points which are at different points, essentially a sequence where the points are separated by different periods, right? So ODE nets looks like it's going to have a substantial impact on the future of prediction. And then finally, in the anomalies area, the autoencoder decoders are essentially a likelihood model. So autoencoder decoders will very easily detect something which is unusual. But really, there's two classes of unusual things. There's things which are generated by your underlying process. They're just rare, right? And there are things which are a consequence of failure. For example, if you're looking at data coming from a sensor network, you can have a sensor actually fail, and then you're actually going to get an erroneous data point. So if you think of outliers as being the first class generated by the underlying process itself, and anomalies being used for the second class, which are actually errors or failures in your data collection system, a generative adversarial network has the advantage of a autoencoder decoder in that it can identify the rare but valid events and build those into the models. So it looks like generative adversarial network is a step forward, right? Again, if we look at the bottom side of this, in ranking, weighted attention, residual attention, and gated attention in the vision area, and in NLP, a fantastic developments in terms of BERT and the basically ordered neuron LSTMs, equivalent steps forward. The key point about this, folks, is not what are these technologies. The technologies themselves are great. The key point is, in 18 months, our landscape has changed almost completely, right, in terms of what is state of the art. So the challenge for corporations, for companies, in dealing with AI is keeping up to date with what's happening in the field, right? Okay, sorry, that one. Let me move forward. Okay, So let's get on to the final section of the talk, which is about the disruptive technology. So what is a disruptive technology? It's really got three characteristics, right? It creates a new approach product to market, right? And without a doubt, machine learning AI is creating a substantial new approach to a lot of problems. It impacts an existing market. Now, if you think about the existing markets, anything like travel, accommodation, healthcare, insurance, fintech, manufacturing, even oil and gas, resource extraction, all of those markets are being affected by AI. I think it wouldn't be too much of a stretch to say that AI is essentially affecting every market out there. So looking at AI as a disruptive technology, certainly the first point is met. Certainly the second point is met. The third point, though, is disruptive technology displaces existing market-leading firms and supply chains. And I think that's something that doesn't have to happen. So looking at it, what is AI changing within a corporation? It's changing your need for a group of human experts, right? People who have significant amounts of domain knowledge, who can come up with the algorithms or the processes to deal with whatever problem you're dealing with. Now you can essentially move some of that algorithm design work onto the machine. You still need business experts, right? People who understand the nature of the business they're in, but you don't necessarily need to build the algorithms yourself, right? The second thing is subtle patterns, right? Where you have vast amounts of data. Think of problems like oncology, cancer, right? With vast amounts of data, finding those patterns is actually quite tough to do, right? AI takes a lot of that business of finding that pattern away from the human folks working in the area. Patterns which are hidden, patterns which are incredibly complex, AI can help with those as well. But perhaps what's more important is what AI doesn't change, right? The first thing is the value of proprietary data. If you're a market-leading company, you have access to a data stream. That data stream enables your AI team or consulting company, however you're trying to do this, to actually build a superior model, right? The second thing that AI doesn't change is market credibility. Essentially, your customers' trust in your company as supplying the service. So moving on, if we want to get to a point where AI is not a disruptive technology, then the key things that need to happen are the leadership of the market-leading corporations need to embrace AI quickly, right? They need to commit to using their proprietary data to build superior models, okay? And they need to use the market credibility to maintain the data streams, essentially to continue giving them up-to-date, better information than anybody else has, and then deliver the value of AI to their customers as soon as possible, right? If they manage to do that, then there's no reason why a leading company should be disrupted. How does this happen? Well, folks, this, I think, is the timeliness fashion. The point of going through what is changing in AI over the last two years, 18-month time frame, is to say that it's an excessively fast-moving field, right? And there's already tremendous capability. If you're a large company without a data science team, you really don't have time to build one. If you do have a great data science team, get behind it, push the capabilities of that particular team, deploy it as quickly as possible. If you don't, find one of the many specialist companies, right, ourselves being one of them, who are willing to work with those market leaders to bring the value of AI into the company, right? So really, the key message of this talk is the following. Market leaders who basically become AI-enhanced companies are going to continue to be market leaders. Market-leading companies which ignore the promise and the value of AI are probably going to see their markets consumed by the AI-focused big tech companies, right? Think of the, basically, Googles, Facebooks, et cetera, of the world. If those companies, those big tech AI-focused companies, are given the opportunity to establish name recognition and credibility inside the market, then it's game over for the existing market leaders. If the existing market leaders use their time wisely now, right, then they can stave off essentially the market disruption. Okay. And that's everything for today's talk. Very happy to continue to talk about any of the aspects that have been in the talk afterwards. Otherwise, I think we've got a few minutes for questions here. Okay.
Hi, Hugh. You were talking about trends of AI, and one of the trends I expected to see and didn't see on your presentation was ethics and the debate, entire area around debates, ethical AI. So any thoughts?
I do have thoughts about the ethics of AI, right? AI is one of those tremendously powerful technologies out there. If misused, right, then it has substantial negative impacts on quality of life. But I don't think it's unique to AI as a technology or a particular area, right? If you think of almost every technology which has substantially changed our lives, those technologies have both had the ability to negatively affect our lives and positively affect our lives, right? You think of nuclear power, for example. When viewed as basically as a source of energy for countries, you can think of nuclear power as being something very, very positive. When you think of it as being weaponized, has significant potential to negatively affect us. So I do think that there is an ethical consideration about AI, and I think we as practitioners need to be very, very careful about what it is that we're doing, right? But I don't think it is a unique problem to the AI field.
Sure.
Thanks. Okay. Anybody else, folks? Okay. If not, thanks very much.